Welcome to today's lesson, which is about solving equations. And today I will demonstrate my ability to solve equations with fractional coefficients and decimal coefficients. That is our I can for today, and those are the things we're going to be focusing on as we move throughout today's lesson. To begin, we have a warm-up. You guys should have already started this on your own, and if not, go ahead and get started now. Notice what different signs we have. We have addition and we have division, multiplication, and even subtraction, so be cautious of that. We have a vocabulary recall down at the bottom, and then after we finish, we will have student volunteers go over this and share their solutions. As you can see at this point in time, we have all of the solutions here. I would have had student volunteers come up and share this with the class, as well as how they knew these answers. But for the sake of this video, here they are. Some things I'd point out to students as they are solving is I would like to make sure that they remember with multiplication and division when we use a negative and when we use a positive, knowing we're trying to make one. When we think about opposites with adding and subtracting to make zero, looking at those signs very carefully, whether we're adding or subtracting originally. And then also down at the bottom, the biggest takeaway I want for kids to take are these three that I am boxing in green. We want to talk about how we use the reciprocal in order to make one when we are multiplying with fractions. That's going to come in useful later when we are solving problems with fractional coefficients. To begin today's lesson, we first need to recall things we have been previously learning, and we need to know our 4 steps for solving linear equations. What is that process we've been using? Because we're going to be using it again today. The first thing we need to do every time is we have to distribute. We apply the distributive property to get rid of any parentheses. After we distribute, we would combine like terms. With the like terms, we're looking at things on either the left side or the right side of the parenthesis that can go together to make sure that it is as simple as possible before we start moving things around. Step 3, we are going to use the additive inverse. This is a vocabulary word we should know already. And what that really means is that we're going to undo any adding or subtracting that we see. Even though it's called the additive inverse, it does apply to both addition and subtraction. And then last but not least, we will use our multiplicative inverse, where we will undo our multiplication or division that we might see. This is our process that we've been following in our units so far when we've been solving equations with integers, and now we're going to keep applying that with the rational number ones with fractions and decimals today. On the side here, I have a note for the students to notice. The process won't change even when we add rational numbers like our decimals and fractions. So to start off, I want students to go ahead and solve this first problem. I'm going to have them talk me through how we solve. And for the sake of this video, I will talk through it myself. The first thing we always do is we draw a line through that equal sign to make sure that we keep our balance when we are solving. And then we're going to go through our 4 steps. We're going to distribute first. So we're going to take 2 times x to make 2x, plus 2 times a positive 5, which makes positive 10. And then we copy the rest of the problem. Negative 4 equals negative 6. We could also read that as minus 4. They are interchangeable. Next, we have combined like terms. We have to identify, do we have any like terms? Yes, we do. I see I have 2 numbers I can combine, and I know 10 minus 4 is 6. So I have 2x plus 6 equals negative 6. Next, we have our additive inverse. So I'm going to undo this plus 6 by subtracting 6 to both sides. Here we made 0, so it is gone. That's why we use our inverse properties, and I'm left with the 2x on the left side. And then we need to make sure that we apply our integer rules properly here. So we have to be extra careful. Negative 6 minus 6 is negative 12, not 0. And then last but not least, we are going to use our multiplicative inverse. I see I have 2 times x. I know to undo multiplication, I'm going to divide by 2 to make 1, which leaves me with my x. I'm going to do the same on the other side, divide by 2, and I'm left with a negative 6. Being extra careful to watch our sign, and we have x equals negative 6 for an answer. And what I want students to understand is when we look over here at this decimal problem, it's going to follow our 4 steps still. The process won't change. We just are adding a decimal into the problem. So just like we did on the left side, we're going to start with our distributive property. We're going to take 2.2 times x, which is 2.2x. And then we're going to take 2.2 times positive 5, which is positive 11. I then recopy the rest of the problem. Negative 4.8 equals negative 7. Next, we look for like terms. Once again, I have 2 numbers that I can combine, just like I did over on the left side. And so I'm going to have 2.2x. When I combine those like terms, I have plus 6.2 equals negative 7. Next, we're going to keep following our process. In step 3, just like we did here, we undid the plus 6. So I'm going to undo plus 6.2. I'm going to use my additive inverse, and I'm going to subtract 6.2 on both sides. In doing so, this cancels out. It makes 0. It leaves me with 2.2x equals negative 13.2. Once again, I will stress to the students to be careful with their integer rules over here. And last but not least, using that multiplicative inverse. Over on the left side, we saw it was 2 times x. And over on the right side, we have 2.2 times x. To undo that multiplication, we will divide by 2.2. We have to do that on both sides to keep our balance. We get 1x over here. And on the other side, we end up with negative 6 once again. So we had 2 different problems. They followed the same process, and coincidentally, we got the same answer both times. For our next problem here, it's a you try problem. So I'm going to have students work with a partner, and I'm going to have them solve this problem. While they're solving, I'll be walking around and listening for conversations, making sure that they are understanding the process, applying all of the rules correctly, and listening for students that are explaining it exceptionally well. Those are the students that I would ask to come up to the front and share their process with the rest of the class as they all check their answers. Also, during this time, if I hear anything that is way off, I will also step in and try to prompt the students into finding what I had to interrupt and what their mistakes were. And hopefully they can come to that solution or that correction on their own. And if they can't, I'm there to provide that guidance. If you are curious about the correct answer, it is negative 4.8 equals x. I chose this problem specifically because it's written in a slightly different order than the ones we did together. I have the solution on the left and the problem on the right. That sometimes can cause a problem for students. And the other thing that's different about this one is here, when we are combining our integers, they're not both negatives like our example problems. We have one positive integer and we're subtracting an integer from that, and it gives us a slightly different answer. So students are going to have to be extra careful with their integer rules when solving this problem. So those are good things that I'll be looking for to make sure that students can apply this understanding to all problem types. Now we're going to move on to fraction coefficients and fraction values in our problems. And so once again, we have an integer problem and we have a new problem next to it. Let's go ahead and solve that integer problem together. For this one, I would have students walk me through how to do this, but for the purpose, I'll be leading. We start with step 1, which is we distribute. We're going to take that 3, distribute it into our parentheses. It's going to give us 3x minus 21 minus x equals negative 5. Second step is to combine our like terms. This time we are combining our variables. We have a 3x here, and we have minus x here. We always like to sneak in a 1, just so students can see it is a value there. So we have 3x minus 1x, which leaves us with 2x minus 21 equals negative 5. Additive inverse, I have subtract 21, so I'm going to add 21 on both sides. That's my opposite. We created 0 here, left me with a 2x equals 16. And the multiplicative inverse, this is 2 times x. I'm going to divide by 2. I'm going to do that to both sides. We are left with 1x, or x equals 8. Our next problem is the following with fractions. It's extremely similar to the one we just did, and we're going to be able to reference back to that first example if we get stuck about why we are doing something. Like we did on the left side, we distribute first. This time we're working in fractions, so we might have to slow down a little bit. We first start with 2/3 x plus, and then we have to figure out 2/3 times 15. If you know it off the top of your head, great. If not, we can go over to the side and do the math. We have 2/3 times 15. Here I'd probably ask a student to lead me through how we multiply fractions together. We have to add our denominator. We're going to multiply straight across, get 30 over 3, and we know that really means division, which leaves us with 10. So even though we started with a fraction, we ended up with a nice integer. And then we're going to copy the rest of the problem. Minus 1/3 x equals 32. Next, we need to combine our like terms. Just like on the left side, my like terms are variables in this example. So I have 2/3 minus 1/3. Make sure we catch that that's a minus sign there. Leaves me with 1/3 x. And then we copy the rest. Plus 10 equals 32. We have to apply our additive inverse, so we have to get rid of that addition or subtraction. We did it on the left side. Now we're going to undo that plus 10. The opposite would be to minus 10. We've created 0 there, so we're left with 1/3 x equals 22. And then last but not least, we have our multiplicative inverse. Here is where we differ from most problems. Because our coefficient is a fraction, we need to go back to that warm-up where we have to use our reciprocal. I like to set up a little multiplication box, honestly. And I'm going to ask myself, what am I going to multiply 1/3 by to create 1? We are trying to eliminate that. I know, based off our warm-up, it's going to be the reciprocal, or that fraction flipped over. It's going to be 3/1. It's going to cancel and leaves me with just my variable x. But because I multiplied by 3/1 on the left side, I need to keep the balance and do it on the other side. The beauty is, it's over 1. I don't really need that denominator, so I'm just really multiplying my two numerators together. 22 times 3 leaves me with an answer of 66. So my answer is x equals 66. And lastly, I would once again have students partner up, and they're going to do this you try problem with their partner. Once again, while they're working, I'm going to be listening to their conversations, making sure that they're not making any common misconception mistakes. If they are, I'll address it immediately with them or with the entire class, depending. I also am going to be listening for a group who is doing a really nice job explaining their steps and thinking through each problem, so that they can come up and share with the class how to correctly solve this. This one is a little bit trickier because our fractions get a little bit more complicated, but it's very similar. They don't even have the distributive property to worry about in this example. If you are curious about the correct answer, it is 126. And when the students solve this problem, something I would have them talk about is we solved multiplication with fractions up above where we multiplied straight across. I would encourage them to use the cross reduce method when they're solving this problem, simply for the fact, I'll put that over 1, that 36, 7 are pretty big numbers to work with, but if they cross reduce, their numbers get smaller. So that's something we can talk about as a recall for them, which would be helpful for some students. If that's beyond where their comfort is or what their capability is, they can always use this multiply straight across and then divide method. So there always are options, but I like to expose students to all of the possibilities for them.